Good morning, everybody. Thank you very much for the opportunity to speak this morning. I'm Robert Staunton, Research and Innovation Account Manager at the RSSB, and
I'm Neil Gofton, Lead Track Engineer at RSSB.
we're going to talk to you about assessing the railway as a whole system, and in a way to try and find new improvement areas. So, whole systems approach. On the left, you've got an example of where two people have done their job possibly correctly, but together this doesn't work. And on the right-hand side is a funny example I found. It's a toy train I got from my son, and written on the side of this train, you wouldn't believe it was, it's a compatible with other leading rail systems. That's a bit over the top, but I like it. But in reality, the whole system sort of looks like this. Today, a lot of people are going to be talking about the track system, and it's very complicated. You've got your rail, you've got your sleepers, you've got your ballast and your subsystem, you've got the environment around it. There's a lot to do. And the old joke that the track would be in great nick if they just didn't run trains over it. But somebody did bring trains to it. They brought trains, they brought power, signals, and platforms. Things got more complicated. And then they added people. What a disaster. And not just people, they then call them customers. So we have to treat them differently. And then you get a picture when you zoom out again one more time. You get a view of all the different considerations that can happen in the railway. And this can be infinite. I mean, you have to call it a day eventually, because as more considerations come in, they have less and less of an influence, so you can define your whole system. And at the RSSB, we're an independent rail industry body, and we're a membership-based organisation. We are created to hold the standards for the industry independently, and also to keep an eye on safety of the industry as a whole. So we keep all the safety data and do safety analysis. We have a research programme which is funded by the DFT rather than members, which is 10 million a year. And that research programme is called a Whole Systems Research Programme. So in this whole systems approach, things can get complicated. Even single partners can look at things in a whole system, but their whole system. But there might be one parallel to that, and they might be part of a bigger whole system. So it's just a way of keeping in mind what else is happening around you. And on our railway, it is difficult, because you don't just have one location where you've got the considerations to make, but you've got locations in the southeast of England, you've got Scotland to consider, you've got Wales. And not just how it changes per location, but some of the assets will last 40 years plus. So you have to consider what's going to happen to them as time passes on. And it makes it really, really complicated. And to be honest, in our jobs, everything is different in the RSSB. We won't be the greatest technical experts that you'll have in front of you today. But what we do have is that we get a variety. We get to see absolutely everything that happens in the rail industry. An average day for me, I'll be looking at things like seat comfort in the morning, and then by the afternoon, somebody will be talking to me about plastic deformation on rail, or about environmental sustainability in plus 20 years, and somebody seeking to present at a UN meeting. We cover an awful lot. But we're going to show you just a few, I'm going to show you a few examples, and Neil will dive into a few more P-way ones. This example here is around adhesion. And as capacity demands have gone up, we've lengthened the trains. But really all we've done is taken one short length formation and added a second one and put them together, and they act as one. What's on the first train is also on the second train. So the leading train has got sanders on it. So does the second, but we used to always leave the second sanders off. And we used to leave them off because of sand-induced wrong-side track circuit failure. And that's where the train sits on the rail, but people were worried that if there's too much sand between the wheel and the rail, that it wouldn't complete the signalling circuit and the train could go undetected. If you can go undetected, it could lead to a collision. And that risk prevented people from turning on the train instead of sanders. What we can do at the RSSB is take a whole systems view and go, okay, so that's the sanders risk. But what happens when we look at the adhesion risk? What's the risk to people, passengers, service, when you think about not being able to stop? And that reframed the problem and went, this is serious. This is also serious. This is 170 times more serious. So let's look at what we can do about turning those sanders on. And when they did turn on the sanders, they were able to gain about a fifth improvement in the stopping distance. But it opened up the way for even further research last year, which then got us looking at the double variable rate sanders, and we did extensive trials, and that brought stopping distances down by half, which is really dramatic. Another example comes from sort of the signalling world, where we have temporary block working and emergency special working. When something like cable theft happens and the signalling system goes down, we want to continue to operate services, but without the signalling system that we rely on. So these are our fallback methods. Temporary block working had a number of steps symbolised there by the circles that you can see. And people knew emergency special working could be done with fewer steps. But when they looked at it, for a long time they were dissuaded by the risk. Emergency special working looked more risky than temporary block working. But that's when you considered what was happening down and there. When you think about what happens to those passengers that would have to take rail replacement services, the situation changed and you can do a new consideration. Similarly, emergency special working on a move-by-move basis could look safer. But when you consider the fact that if it's easier to use and it's quicker to deploy, you'll use it more often.
Sorry, Ron. Speak closest to the microphone for the back.
I've gone wandering. Can everybody hear me now? Sorry. So when you look at this, you can reframe the problem and how things look. And emergency special working has gone into place now this December. And it was this balance of risks and the detailed analysis of it which unlocked this to be implemented. So the advantage as well is that emergency special working can be deployed within, on average, in 70 minutes, while temporary block working took 140 minutes. And emergency special working has been deployed in as quick as 20 minutes. And that makes a big difference to passengers and to platform staff who have to deal with frustrated passengers and the abuse they might get from them. Also, passengers on trains that are trapped, taking things into their own hands and self-evacuating, and the risk that brings into the railway. So it just shows how a different approach can open up things and provide a new perspective. So for 2.1 million of training and briefing costs for the whole industry, there's an annual return of 3 million. But you might go, the RSSB, do they really know about this stuff? They don't own any trains, they don't own any track. Well, we try not to own assets. But if you don't own assets, you quickly end up in a position where, how can you work with them if you don't own them? You don't have anything to play with. And that leads us to the fact that we need to work differently. And when you take a whole systems approach, you eventually go so far that you don't own the things that you want to influence. And in that case, you need to partner up with people. You need to find a common ground to work with them and get them to buy in with you. And you need to communicate and engage with them really well. And really, that becomes collaboration. It's all about that. At the RSSB, day in, day out, we've got to manage our stakeholders, bring everyone along, and try and work with everyone. And that's symbolised by the fact that we really help the industry to bring in change when we don't actually control any of the railway. So we use a remit as well. And normally a remit's described as a remit, that's just an excuse for not doing it. Or, don't give me remit, I need a solution to this now. But a remit helps keep us true. And what it does is, you can see the key ones are the red squares in the bottom left-hand corner. They say, if it's within the hands of a single group, and if it can deliver an incremental or achievable change in a short time limit, then actually the RSSB doesn't want to do that work. That should be down to the parties involved. Because if we get involved, we're going to muddy the waters and we're going to cause more harm than good overall. And actually, what we want to do is to pick the right areas to work in. Be careful not to step on too many toes, but to be effective and on the whole, achieve a betterment for the rail industry. So this comes as sometimes that can be a frustration that people see from the work that we do, but actually it comes as a condition of the research money that we get from the DFT, and actually it's quite a good thing. So please keep that in mind. So our research approach, I mentioned the DFT, we work with industry and the DFT at all stages. But in the centre, you can see the key thing I wanted to mention here was our delivery mechanisms. We've got a whole toolbox of different ways of delivering change in the railway or investigating it. So we do internally delivered work. For example, we've got a great human factors team at the RSSB. They can do research and then put out real guidance and changes to industry. We do open procurement. I hope there's a lot of rail industry suppliers and consultants and contractors in today, and that you've gotten some of our work in the past. All of our T-number projects go through open procurement. We do calls as well with university and the rail industry suppliers. And then we've got strategic partnerships with people like the University of Huddersfield, where we set up a framework and we work with them to develop that collaboration approach. Grant schemes as well. So if industry and your company really actually want to answer a rail industry problem, if you're willing to share the results of that, we don't mind putting in the money. We don't need to do the work. We just want to get the results out for the industry. And European research. We get involved in a lot of European research, and Neil's going to give some examples. But that's true, the work that standards teams do, working in Europe and then getting involved in different projects and the opportunity to bring European-based initiatives back to the UK. Other ones we do, innovation, knowledge services, we do horizon scanning on behalf of the industry, and we're a key supporter of Ukraine. We have all these different tools in the boxes so we can pick different approaches for the right stakeholders and the right type of problem. We also do it as well to bring on industry's capability and to make sure that the supply chain continue to offer their capabilities. So if we're doing a lot of work with universities, it is really great sometimes when you get a small company who's involved in a research project with us, who sees the capability of the university and what they can do, and actually then afterwards continue that relationship with them to solve their own true business problems, not just the RSSB funded ones. I'm going to hand over to Neil now, who's going to give some really great P-way examples of how research falls into those categories.
Thanks, Rob. Yep. So yes, as Rob said, I just thought I'd highlight a few examples of projects that sit across that funding framework, things that I think might be of interest to this group. I think, as Rob said, it's very important to think that actually we're not a group of people sat in a dark room churning through lots of technical output and putting it out to industry. Actually, it's all about you guys and getting you guys involved in these projects. So some of you here will recognise a number of these things I'm going to talk about. So we start with a call. So the New Materials Challenge call was launched back in 2014 as a joint thing between EPSRC and RSSB. And this was looking about what new materials could be brought into the railway and how we could develop them to help reduce whole life costs. And so I'm going to mention 3 of those projects that were funded. First one was New Rail Steels that was led by the University of Huddersfield. So this project sort of went into the metallurgy of the different rail steels available and went through a series of testing, understanding wear and damage mechanisms, and then actually starting to understand help to understand the problem of what's the right rail steel to use in the right situation. Moving on to the laser cladding project, which was led by the University of Sheffield. And this is actually about using additive manufacturing to get functionally graded material for critical rail components, critical track components like rail. So actually, what materials could we put onto the surface, the contact surfaces, to improve the performance and reduce damage mechanisms? And this project's gone through a series of looking at different types of clad materials, what works, what doesn't, and actually done some full-scale testing of some examples like insulated rail joint by cladding the rail ends to reduce and see a reduction in rail end damage. And then moving on to the last one on this slide, the novel materials for drainage. What materials used in drainage outside of the rail industry could be brought across into the track drainage system, what improvements could be seen, and how we benchmark those against a conventional track drainage system, and then what the reduction in whole life costs can be. So 3 examples sitting at different points of the system as trying to understand where at those interfaces we can deliver some improvements. So we'll move on to an example from the open procurement route. And I should say these aren't by no means intended to be technical representations of any of these projects. It's just really a flavour for everybody to understand what's going on. But in the open procurement route, I've highlighted the T1073 project, which is a project looking at track loading requirements for track systems. Now, this isn't about alignment design or anything like that. This is purely about track system design. And why, really? It's a pretty fundamental piece of research. Why are we doing it? Why now? Well, I guess the track system itself has probably evolved over the decades and centuries of its history, going back from when the examples that Sinsin mentioned earlier. But actually, what do we design for if we want to design a track system? And as we're getting more creative with our track systems, we're pushing different alternatives of ballastless track system, and indeed hybrid systems. We're going to hear about asphalt track later on today. But what do you design for? What's the loading regime that you should design for? If you go to railway group standards, you get to a set of limit values okay, that's great, but how do you apply those? It's not a lot of helpful information there. If you go to the European standard for ballastless track, you get steered towards structural Eurocodes and load model 71 and some fairly sort of binary load amplification factors, but is that appropriate for general track system? So the project's been going on for a few years now. It's sort of been tackled in two parts. The first part looking at a bit of across industry, looking at best practice for track system design, what loading regimes are applied and how. And that compiled a bit of a literature review, which was published probably 2 years ago now. And the second part that's been ongoing for the last year or so has actually been looking at some quite detailed models, looking at modelling the track, the vehicle track interaction and the track soil and substructure interaction. And I guess I've put this example plot up here from out of some of the research, and it's not intended to be taken away as an answer, but what it's trying to illustrate, actually it's not necessarily one size fits all, and actually the load amplification factors should vary depending on the vehicle type, the track type, the soil stiffness conditions. So that project is drawing towards a conclusion, and hopefully there's publish some outputs in the not too distant future. So going on to strategic partnerships, a couple of projects are highlighted from the strategic partnership with the University of Huddersfield. The first one looking at the initiation and development of squats. So this project's looked at rail defects across the network and looked at parts of the network where there's a high propensity for the development of squat type defects. And it's doing a multi-parameter analysis for all the system parameters, both operational and technical parameters existing in those areas, and trying to understand what are the key things that correlate with the development and propagation of squats. Things like traction and braking zones, whether it's approach to signals, what are the support conditions, is it curvature, all those kind of parameters featuring into this project. And hopefully the output will steer us to industry to better understand where we need to prioritise action against these damage mechanisms. And the second one, looking at plastic flow, which has done a quite detailed finite element analysis, looking at the contact conditions and trying to challenge and further develop our current models for plastic flow. Hopefully moving us to a place where we're predicting the plastic flow damage mechanism as well as we do with RCF currently. And the last category I wanted to mention was European research. So I was going to pick up on the ESCO project. So this is a project under Shift to Rail, being delivered by a consortium led by Birmingham University, but ESCO are part of that RSSB are part of that consortium. And this is looking to sort of a 30 to 40 year horizon, and its targets looking at next generation switches and crossings. So it's about understanding what we know about switches and crossings today, the way they perform, the way they're designed, and what would we do if we had a blank sheet of paper today? What were the next 40 years, what could it look like? And that project's looked at some interesting concepts, looking at things like sort of back-to-back bistable switch, employing some of the principles that Repoint's explored, single slender switch, trying to reduce the complexity of components trackside, and even vehicle-based switching to actually trying to eliminate movable components on the trackside. But it's not just about exploring interesting concepts, it's actually about looking at what the technologies and materials that are needed to make those happen. And not just what we can use out of those materials and technologies to make new concepts happen, but actually what can you apply to a conventional type switch configuration that delivers some benefit. So some of the things I've picked up out of the project that are probably most P-way related are things like neo-ballast. So this is exploring applying a rubber coating to granite ballast, conventional granite ballast, looking to improve interlocking capabilities and load transfer. Functionally graded composite bearers, trying to get some benefits out of designing a composite bearer that has better interaction with ballast. Self-healing and high damping concretes are in there. Wear-resistant contact layer. We've already talked about, I've already mentioned the rail cladding. This is looking at some other additive manufacturing techniques that we could apply to get better wear and damage resistance in around critical components like switches and wheel transfer areas of crossings. And some interesting concepts looking at some dynamic stiffness fastening systems. I should say that project then feeds into track 2, which probably going to hear about in the next presentation, which is continuing under the Shift to Rail umbrella. But where does all this stuff go? Well, some of these things I've already mentioned get picked up in further R&D programs and get taken forward to a higher state of technology readiness level. But other things actually, in the nature of the research that we do, which tends to be around the interfaces, actually leads to changes in best practice and the need for standards change. And it comes back to the whole system approach. By getting the right people involved in the research and development at the early stage, hopefully enables us to make that transition into standards and making it available for industry to use and put into practice far more smooth and consistent. So I think Rob's got a few final comments to close.
Yeah, we'd just like to stress how beneficial it is for the industry to have the standards organisation in the same place as a research-based organisation. So often, standards are facilitated by research. So if there's a concept out there, but there's not the grounds to straight away go and do it, it can be quickly and easily transferred over and the research be done to answer the question to make the standards change. And then when we do research, which might be that blue sky thinking or the research that will better an awful lot of parties, but not one massively, significantly, then we can do the research, come up with the answer, and it can be passed over to standards for them to make the change. And it really is a great symbiosis that exists and facilitates an awful lot of change within the industry. And our last slide then is just to say that we want you guys to use what we have. So every project that we've mentioned there will be available on our knowledge sharing platform, sparkrail.org. Any queries you have that the RSSB could answer, we've got a portal there, and that will get you to the right person, regardless of who you know, if you've forgotten somebody's contact details. And you can give myself and Neil a shout at any stage. So if you have had a concept that you think, I know this is good, but I can never just make it work on the numbers, give us a shout, because there may be a whole systems approach to seeing why you think intuitively that there is that benefit in it. And we really want industry to use this. We don't want our research, we don't produce it to be a project and a document that sits on the shelf. We want industry to pick it up, and more, I talked about the remit, but more and more we're getting closer to working with people in implementation to really bridge that gap. We truly understand the difference between something that's possible and something that gets done. And we want to work with more people to do that. So really happy to engage with everyone. Please give us a shout afterwards. Thank you very much.